Okay, so what about when we have to put all of these rules together? There's again a lot of different ways to do this, but I try to go with what is the easiest method, and one thing I always do is try to follow order of operations. And a lot of times if you have problems with negative exponents in it, it's going to be easier to get rid of the negative exponents in the beginning. So let's look at this first problem right here. A to the negative 2, b to the negative 5th, all over ab squared times a to the negative 3. What freaks me out about that is all the negative exponents. Recall from the beginning of our notes, to simplify means there are no powers of powers, each base appears only once, all fractions are in simplest form, no parentheses, and only positive exponents. So going back to this problem, the first thing we've got to do is get rid of these negative exponents, and then that way we'll at least have that part of our simplifying done. So I'm just going to draw our division bar here. B squared in the denominator is the only thing being raised to a positive exponent, so it will not move. Go ahead and just distribute that square there. That would be a squared, b squared, and those will stay in the denominator. How else? Everything else needs to move. So a to the negative 2 moves downstairs and it becomes a to the positive 2. B to the negative 5 moves downstairs, it becomes b to the positive 5. And then this a to the negative 3 moves upstairs and becomes a to the positive 3. From here, let's simplify our numerator and then simplify our denominator. So the numerator is good to go. In the denominator, we are multiplying like bases, so we'll add the exponents. A squared times a squared gives us a to the 4th. B squared times b to the 5th gives us b to the 7th. And then last but not least, we will divide. Right here, because we have a cubed in the numerator and a to the 4th in the denominator, we are dividing like bases. We subtract the exponents. 4 take away 3 is 1. The larger exponent was in the denominator, so this becomes a to the 1st, b to the 7th in the denominator, and left in the numerator is just that 1 to hold that spot. All right, we're going to use the same approach with this next problem. We're going to start by getting rid of those negative exponents. So since this entire product here is being raised to the negative 3 power, we're going to pick it up and move it downstairs. So that becomes negative 3xy squared, now all raised to the positive 3. Nothing in the inside changes. You just pick it up, move it downstairs, that negative 3 power becomes the positive 3 power. 2 is not being raised to a negative power, so it stays right where it is. And the y to the 4th is raised to a positive power, so it stays right where it is. But this x to the negative 6 right here needs to move up to the numerator. When we cross the line, it changes its sign. It becomes x to the positive 6. We're going to do the same thing we did in the last one. We're going to simplify this denominator, and then in the end, we will divide. So, negative 3 cubed. If you need to, just go over to the side of your paper. You're saying negative 3 to the 3rd power. That is really negative 3 times negative 3 times negative 3. When we multiply 3 negatives, we're still going to have a negative. 3 times 3 is 9. 9 times 3 is 27. You can also check that on your graphing calculator in Desmos. So that's going to be negative 27. And then right here, we have x cubed, power to a power multiply, y to the 6. Times 2y to the 4th. So this x to the 6 is going to stay right where it is. We're now multiplying in the denominator. So negative 27 times positive 2 is going to give us negative 54. X cubed is just going to stay right by itself because I don't have any x's to multiply by. Y to the 6 times y to the 4th would give us y to the 10th. Now that we have simplified the denominator, we will divide the numerator and denominator. We can see right here we have x to the 6th in the numerator, x cubed in the denominator. We are dividing like bases, so we subtract those exponents. 6 take away 3 is 3. Since the larger exponent is in the numerator, that x cubed will stay in the numerator, so that will become x cubed over negative 54 y to the 10th. And there's our answer. A lot of times if this is multiple choice, you will see the negative be moved in front like this, negative, and then it'll be x cubed over 54 y to the 10th. Or you might see the negative be moved to the numerator. It doesn't matter just as long as it's there. All right, copy down these two problems, then pause the video and work them out, and then restart the video to see how we did. Okay, so for this first problem, number 9, We have to make sure we pay attention to the fact that this second product right here is being raised to the second power. Therefore, we have to take care of the powers before we multiply. So all I've done, when you see the first way I've worked it out, is I've copied the first product, this 8x to the negative fourth y cubed. And then for the second part, I've gone ahead and squared it. So negative 2 squared, think about that. That's negative 2 times negative 2. So we get positive 4, which is where I'm getting the 4 right here. And then power to a power multiply. So x to the 5th squared is x to the 10th. Y to the negative 6 squared is y to the negative 12. Then, instead of getting rid of the negative exponents, I went ahead and just multiplied. 8 times 4 is 32. When we multiply like bases, we add those exponents. So negative 4 plus 10 gives us 6, so that's where we get the x to the 6. And y cubed times y to the negative 12, 3 plus negative 12 is negative 9. And in the very end, because we still have negative exponents, I pick up this y to the negative 9, move it to the denominator, cross the line, change the sign. Notice, we don't have any parentheses left, no powers of powers, each base appears only once, and only positive exponents. Another way you could have done this problem is where I've worked it out in green here, where I get rid of the negative exponents from the beginning. So in this first product, I move the x to the negative 4 downstairs, so it becomes x to the positive 4. In the second one, I move the y to the negative 6 downstairs, so it becomes y to the positive 6. Again, just like the last problem, I have to square this second quotient before I can multiply using order of operations. So I copy the first quotient, and the second one, negative 2 squared is positive 4, and then we get x to the 10th, y to the 12th. Now we can multiply. 8 times 4 is 32, and then I just did it in alphabetical order, x to the 10th, y cubed in the numerator. In the denominator, we would have x to the 4th, y 12. And then last but not least, we're dividing like bases. We subtract those exponents. 10 take away 4 is 6. We had more x's in the numerator, so that x to the 6 remains in the numerator. And then 12 take away 3 is 9. So 3 of those y's have reduced out, and we have 9 left here in the denominator. Either way, we're getting the same answer. All right, then the last problem, again, we've got to follow those order of operations. We have to make sure we cube this numerator before we move anything around. Don't even try to get rid of that negative exponent. It would just get really ugly. So go ahead and cube all of this. So 3 cubed is 27. And then we have m to the 6, p to the negative 6, q cubed. All over, and then I just copied the denominator. I went ahead in this case and simplified a little bit first. So 9 goes into 27 3 times. I immediately noticed that cubed divided by q cubed was just going to reduce. Even if you did subtract the exponents, 3 take away 3 is 0, and anything to the 0 power is 1. So then that left me with m to the 6, p to the negative 6, m to the negative 3. At this point, I then moved any bases that had a negative exponent. So the 3 carried over, m to the 6 stayed, m to the negative 3 moved upstairs, became m to the positive 3, and p to the negative 6 moved downstairs, became p to the 6. Last but not least, we are multiplying like bases, so we add those exponents. So m to the 6 times m cubed is m to the 9. And we are done.